This time, we are going now to decode a message. So we are asked to use the inverse of matrix A to decode the cryptogram given to us. Now, this is our matrix key. And what we were told is not to use the key, but to use the inverse of it to decode our cryptogram. So first, we need to find the inverse of A. And we can do this since this is a 3 by 3. We would need to use Gauss-Jordan elimination to find the inverse of this specific matrix key. We leave the Gauss-Jordan elimination to our viewers. This will actually result to having this specific matrix. -1, -10, -8 here, 0, 1, 0. Then -1, -6, -5, 0, 0, 1. Then this becomes 0, -1, -1. Which means, I'll be writing it here, that our A inverse is equal to the matrix -1, -10, -8, -1, -6, -5, 0, -1, -1. Now, this is now what we would have to multiply to this cryptogram, group into matrices, so that we can decode it. So, since this is a 3 by 3 matrix, we would need to group our cryptogram into matrices that are 1 by 3, as such. So, to decode this first row, we need to multiply. So let's just bring it down. Here you go. So now we are going to decode. So first we multiply our first 3 numbers to our inverse. There you go. Once we do this, we leave the multiplication to the viewers. We're going to have 13, 5, 15. This now becomes the uncoded row matrix that later on we can correspond to the numbers in the English alphabet. We're going to do the same for the second one here, which is 33, -53, -12. Let's just bring that down again. There you go. Because we need the space, then we'll have -1, -10, -8, -1, -6, -5, 0, -1, -1. Performing this multiplication will give us 20, 0, 13. Let's continue this for all our 1 by 3 row matrices. Alright, we now have all our uncoded 1 by 3 matrices. So, we would need to write them down. We're going to have here 13, 5, 15, 20, 0, 13, 5, 0, 13, 15, 14, 4, 1, 25, 0. So we know that the zeros are spaces. So now we just need to, let's rewrite that 15 more properly. All we need to do is correspond these numbers to the letters in the alphabet. And this is actually 13 would be M. This is M here. This is 5. This is not. Wait a moment. This is not 15 but 5. My bad. There you go. Because this is also E. Then 5 is also E, 20 is T, 13 is another M, 15 is O, N, D, A, Y. This is actually the first message that we have encoded. So if you will notice, this cryptogram here is the answer to what we did when we encoded our message. And now that we have decoded it back to the original message that we had. And this is an example of decoding a cryptogram using the inverse of a matrix and matrix multiplication.